So moving on with the 6502 emulator, last time I did the logical operations, but I didn't do bit test. We just did AND, exclusive OR, and OR. So this time I'm just going to do bit test, and I'm going to stick them in the same file that this one is, and EOR ORA test. It's going to have bit in there as well. So what does this one do? This instruction is used to test if one or more bits are set in a target memory location. The mask pattern is in the A register, is ANDed with the value in memory to set or clear the 0 flag. But the result is not kept, so it doesn't affect the A register. Bits 6 and 7 of the value for memory are copied into the negative and overflow flags. That seems fine. So we'll probably just write a test for that. So let's just call it test bit. And we've got 2 addressing modes as well. Test bit 0 page. So let's just copy something we've got existing just to get something to start with. All this. Right, let's switch anymore. Right, it's X. So this is going to be bit 0 page. Right, and it takes 2 cycles. Just so we give that a name. And we don't need this anymore. Let's just get rid of a bit of this. Just put this back to something that kind of compiles for now. We don't expect anything in the A register. So let's give this a go. So that's the name of the instruction. Something in the A register, that's the bit pattern to test, so I'll stick with a CC. And then it's 0 page addressing, so the next byte in the program has the 0 page address, which is 42, and that's the value in memory to test. So what would be a good test to start with? We could just AND it with itself, and it should get itself back. So if you AND CC with CC, you'll just get CC. That seems fair enough. And then what will happen after that? So the 0 flag, set if the result, if the AND is 0, which it's not. So we expect that to be, expect 0 to be false. The negative flag, now this is the weird one, the negative flag and the overflow flag, which is V. We expect those to just be set to the values that are in memory. So if CC, I think the last 6 and 7 bit are, so that's bit 6 and 7, they're both set on CC. So we should expect both of those to be true. So we expect true on that and true on that. And we expect 0 to be false. And I'll probably just, I'll leave that test the way it is for now. We could probably test that the A register doesn't change because it's not supposed to. The A register will not be affected by that test. And I think that's one test for that. We could do more, I think. So let's put in the actual logical op for it. This is bit. It is 24. And while I'm here, I'm just going to put in the absolute addressing mode for the same thing, which is 2C. Right, so I could probably do the same thing for that one. Absolute addressing mode just has a 16-bit address, doesn't it? Full 16-bit address of the target location. Excellent, so we can just do the same test. Absolute abs. Did define that one correctly, didn't we? Yep. So this one has a 16-bit CDE, 16-bit address, and it is little endian, so we'll go for 8,000, and address 8,000, we put that value, and everything else should be same, except it's 3 cycles instead of 2. So in theory that's a good test as well. I've got the wrong name for the test though, and Eeyore Aura test, I could rename that. Oh no, so it's 3 bytes, it's 4 cycles. 4 cycles for that one. This one is 3 cycles. I was reading the bytes instead of the cycles. That's all good. So I think maybe I'll do another version of this test, another version of the test bit 0 page that has a result of 0. So this is one where the 0 flag should get set. So what would be a good test for that one is if we have if you ended it with 0, it would be 0. That would be one way of doing it. I mean, I suppose we should do something a little bit cleverer than that. Let's just see, because CC is 0011 0011, and can we just not that? Oh, you did it in 16 bits, did you? Okay. Yeah, so that would be hex 33 is basically the inverse of that. So when these two things AND together, we should still get, oh no, we're going to get, yeah, we're going to get 0 because both bits have to be 1 to get the value right. So in theory, if I AND CC with 33, I should get a 0 out of this. I still expect the A register to have the CC in it. I expect the 0 flag to be true. I still expect these 2 flags here to be true as well. And I can pretty much do the same test for the absolute version. And I'll just take this here. Let's try it out again. And this is a 4 cycle version, isn't it? So that's good as well. That's slightly better. We don't have anything that tests that we don't set these flags down here. So I could kind of do the inverse of that, where I put the 33 in there and I put the CC in here. And then I expect the 33 to be in the A register. I still expect the 0 flag to be true. And now I expect both of these to be false. Absolute, I don't know what to call this one. Result 0, bits 6 and 7, 0. Yeah. So we can do the same thing with this one. So yeah, I'll just swap the 3-3 and the CC round. Swap the 3-3, swap the CC, and that's 3-3. And these now become false. Is that right? 0 flag should be true on that one. Yeah, I think that's right. So we should have a few good tests there, I think. Enough to implement that. 6 failed tests. Yeah. So I think we just go straight in and implement that. Implement the 0 page one first. Right. Where should I put it in this giant switch statement? Let's put it after all the logical tests. Down here. So first thing, let's just make sure that we're in. So we should do, first thing we do is get the address. And this is a 0 page addressing. Right, and then we want the value that's in the A register, and we want to AND it with the value at this address. So we probably want to read a byte from the address. Let's read it like this. Just call it value. So we AND that and that together, and the result of that should go into the 0 flag, I think. Are these called flag 0? Okay. So I think that's fine. And then we need to set the overflow and the negative flag, which is the bits 6 and 7. So I suppose to do that, I can mask out bits 6 and 7. Oops, that's B. So if I mask out bits 6 and 7 with the value in memory, that gives me just whether bits 6 and 7, that gives me a value with just bits 6 and 7 set correctly as what was in memory. And then I can just AND that with the processor status. And I think that's what that instruction does. So bits 6 and 7 of the value are copied from memory. Oh no, we want to OR it. Just want to OR that, not AND it. Anyway, we'll see in a minute if that's what we got. And everything still fails. So why does everything still fail? We've used 4 cycles to do it. Really? In what? Test bit 0 page. Oh, really? It's supposed to be 3 cycles, but we've used 4. So why is that? We used 1 to read the instruction, and then we used 1 to fetch the byte, and then we used 1 to read the byte. That was 3. Why did it use 4? Is that what it said it did? I expect 4 for 0 page. I expect 3. I've written the test wrong. Oh, because it's not using expected cycles. Oops. 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 And oops. And oops. That's all wrong. Right, let's go again. Oh God. What have I got there? What's wrong with you? S32. Oh no, I've done this wrong. Again, right, this is wrong. This is wrong. This is wrong. Try again. You're going to compile now. Yep. Oh, so we've still got 6 failed tests. I think this should be different. Test bit 0 page. Cycle use 3. Expected equality. Cycles used, which is 3. And we got 4? What? Yep, because I've done that. Still done that wrong. It's still wrong. Okay. One more time for the dummies. 5. We got 1 test to pass. Excellent. What have we done wrong here? Test bit 0 page, result 0. Expected the 0 flag. Actuals false. We expected it to be true. So have I done this test right? No. Because in this particular test, this is 0 flag is set if the result if the AND is 0. And the result of this AND should be 0. Am I right on that? Let's debug it and find out what it was. Right. Fetch our instruction, which is it. So we get the address, we get the value, 33. And we're going to AND it, AND those together, and we get 0. Set if the result, set if the result of the AND is 0. And so we want to not that. Okay, that's why we write the test, to make sure we got this right. Right, let's see what we get now. Whoops, we got a breakpoint, and we still got 5. Okay, so now the overflow flag is failing on the same test. So let's see. Did we get that bit wrong? Yeah, in this one, the whole result's going to be 0. It's because the result in memory, 33 in memory. I think they are 0 on that one, so I've done that wrong. They are, oops, yeah, they're zeros. So these should be false. Okay, we got that one to pass. What's next? Test bit 0 page result, bits 6 and 7 are 0. So this one, this is the one that's wrong. So we expect, oh no, because we expect true on those, because they are true now. It's because I did these tests and reversed these values and it didn't work out like that. Actually as well, that should be, yeah, 0. Right, 3. Okay, we got another one to pass. Because we haven't handled this instruction, excellent, right. So in theory now this is all, I say in theory a lot. In theory, this one is almost identical, except we address it with absolute instead of 0 page. I would say that's the same, and this probably won't pass. We got a test to pass by doing that. Test bit absolute result 0. The flags are wrong. Because they are saying true and they're not supposed to be true. These are supposed to be false. I did the test wrong. That's one last one. So test bit absolute result, bit 6 and 7. Overflow flag, I'm expecting true, and actually I'm expecting this test again is reversed. It's the wrong test. Because CC's got those bits set and that's what we expect in there. We should probably do a test that's got a mix of bits just to make sure. So that all passes. So that's bit. That's bit done. Might rename this so it's and, EOR, aura, and bit tests. Let's do that. And make sure all that still works. Just a bit of refactoring. That still works. Cool. So maybe I'll just do one test on each that mixes them. So bit 6 and 7 are mixed. And for that one, let's put an actual, we can actually just put a byte value in here. So 1, 0. This would expect that the negative flag would be true and the overflow flag would be false. And in effect here, we don't care about testing the rest of it. We don't care about testing these. And we don't really even care what's in the A register. We can just get rid of all that. Yeah, let's do that. What's wrong with you? That's not been used because we don't test it anymore. Okay, that one passed. We do the same test for the 0 page one as well. So again, we don't care what's in the A register anymore. We only care what's in here. We'll do a different test this time. And don't care about that. Don't care about these. Don't even care about the result. We just care that the overflow flag is true and the negative flag is false. I think that's all we care about on those. Don't even need to copy the CPU anymore if we do that. I think that's right. And cool. So that's it. So that is bit. That's one more instruction. Well, it's technically 2 more opcodes implemented. So bit is done. So I don't know what we're moving on to next time, because we've got all the logical operators now. I don't know. Increments and decrements, shifts, we haven't done those, haven't done branches, haven't done status flag changes. They'll be really easy actually. So there's a lot of easy stuff to get through, but we'll see what we get to in the next one.